Hello, this video is about finding the derivatives of inverse functions in general. The next video will be about finding the derivatives of the inverse trigonometric functions in particular. First of all, I want you to think about what you know about inverses. I have an inverse function graphed in blue here, and then I have a function graphed in blue, and then its inverse graphed in green. And some things that we know about inverses: we know that the domain of the function is the range of the inverse, and the range of the function is the domain of its inverse. We know that the graph is a reflection across the line y equals x. And the reason that it is a reflection is because any point that's on f of x, the reversed ordered pair is on the inverse. You swap all of the ordered pairs to create the inverse function. And then the other powerful thing about inverses is that they undo each other. So if I take f inverse of f of x, I get back to where I started. I get back to x. And the same way the other way around. So those are some important properties of inverses. I want to point out that a comma b and f of a comma, like this, a comma b would be like this point right here. And then that means that, so that's at like 2 comma 1/2, so that means 1/2 comma 2 would be on the inverse. Those are not the same point. They are at different, they're not at the same x coordinate. They're at swapped x coordinates. And that's going to turn out to be important. So this is their slope relationship. The slopes of inverse functions at corresponding points are reciprocals. It kind of makes sense that they're reciprocals because the slope formula is y2 minus y1 over x2 minus x1. And if we've flip-flopped all of our ordered pairs, then our slope is going to be upside down because now we're subtracting the opposite coordinates for the slope. I also want to point out that this does not mean they're perpendicular because they're not opposite reciprocals. They are just upside down slopes. And again, I'm going to emphasize it's not at the same x coordinate, it's at different x coordinates. So this x coordinate is the y on the inverse function, and this x coordinate is the y on the function. So just so you're aware of that. When there's this is on your note sheet, but if you're trying to prove this relationship that they're inverse slopes at particular points, we start with the definition of an inverse. We know that if I compose a function with its inverse, I get back to where I started. So if I know that f and g are inverses, I know that that relationship is true, that I can compose them and get back to x. And so what I do for this proof is I'll take the derivative of both sides of this equation. On the left side, I'm going to do the chain rule because f is the mom function and g is the baby. And I get that these two derivatives, there's only one multiplication in here, remember, that's f prime of g of x times g prime of x. If I multiply those two together, I get 1, which is really the definition of reciprocal. It means that I could solve for either one of those two derivatives and I would get 1 over the other slope. And so what this means in terms of letters is that if a comma b is on your function, then f inverse prime of b is going to be 1 over f prime of a. So it's not at the same location, it's going to be at that corresponding location. There's an example here, keeping in mind that relationship of reciprocals. I have an f of x function and I have its derivative at selected values here. And if I want to figure out, the derivative of the inverse of my function at 0, I'm not going to look at x equals 0. I'm going to look at y equals 0 because it means -1 comma 0 is on F, so 0 comma -1 is on G. And that means that the slopes at those 2 points are reciprocals. So since the slope of F at -1 is -1/4, so the slope of the inverse at 0 is going to be -4. Similarly, if I'm looking for G prime of -3, that means I'm looking for the y coordinate in the table I have of -3. So I'm going to look at this column of my table. I'm not looking here because that would not be an x coordinate on the function. It's the x coordinate on the inverse, so it's the y coordinate on the function. And so that means at -3, I chose a really bad color, at -3, my slope is going to be 1/11. Another example is if I have a function and I can't find the inverse of this function. This is definitely, because we can see the graph here, this is definitely a function that has an inverse, but we can't see it because we can't solve for x. We can't figure out what that function is. I know it's an inverse because I can draw horizontal lines and it passes the horizontal line test as well as the vertical line test. That means that it is an invertible function. But if I try to find the inverse function, I can't. So if I'm trying to figure out what the slope of the inverse is at 5, at -5, then I'm going to look for the point on the function that has a y coordinate of -5. So I'm going to look at this point here, 0 comma -5. If I didn't have a graph, I would be guessing and checking values that might give me a y coordinate of -5. And I can see that if I plug in 0, I am going to get -5. So then I'm going to find f prime. And I'm going to plug 0 into f prime. Not -5, but 0, because I know that f inverse prime at -5 is going to be 1/f prime at 0. So that means that this slope is going to be 1/3 at -5, the slope of the inverse. Okay. If I want to find this one, f inverse prime at 9, I'm going to look on the graph where I think 9 might be, and then I might test that out. So it looks like it's at 2. Is it true that 2 cubed plus 3 times 2 minus 5 equals 9? And it looks like 8 plus 6, which is 14, minus 9, minus 5 equals 9. That is true. So we are, we definitely have the right spot. So then I'm going to find f prime, of 2. And this is the point on the function. 2 comma 9 is on the function. That means 9 comma 2 is on the inverse. And the slope of f at 2 is 3 times 4 plus 3, or 15, which means f prime of 9 is going to be 1/15. Okay. This is the process of inverses. I'm going to leave the last problem for you to try. The graph is shown on my screen if that helps you. If you didn't have a graph, I promise you that the numbers that you're going to use to guess and check will not be terrible numbers. All right, good luck.